Good morning. My name is Johansson and my register number is URK25CS1019. In this video, I am going to explain the application of the least square method for straight line fitting in three different computing scenarios. The least square method is a mathematical technique used to find the best possible straight line that fits a given set of data points. The general form of a straight line is y equals mx plus b, where m represents the slope and b represents the intercept. These values are calculated using summation formulas based on the given data. First, let us consider scenario 1, which is traffic prediction. In this case, we are given the number of visitors and the corresponding number of page requests. The goal is to predict the page request when the number of visitors reaches 6,000. In this program, we first import the NumPy library for numerical calculations and Matplotlib for plot. Then we store the given data into arrays. We calculate the required summations such as sum of x, sum of y, sum of x into y, and sum of x square. Using these values, we compute the slope and intercept using the least squares formula. After forming the straight line equation, we substitute the value 6000 to predict the number of page requests. The result obtained in is approximately 81.1 thousand page requests. A graph is also plotted to visualize how well the straight line fits the data point. So, next in scenario 2, we analyze database query response time prediction. Here, the relationship between the number of queries and the response time is given. The same least squares procedure is followed in the program. We compute the slope and the intercept using the data and form the straight line equation. Then we substitute the value 300 queries into the equation to predict the response time. The result shows that the response time is approximately 88.1 millisecond. This demonstrates how system performance can be estimated using mathematical modeling. So for the in the scenario 3, we consider machine learning training time estimation. In this case, the data set size is given in gigabytes and the corresponding training time are provided. Using the least squares method, we again compute the slope and intercept. After forming the straight line equation, we substitute the value 12 gigabytes to estimate the training time. The result obtained is approximately 53.3 minutes. This helps in predicting computational requirements for larger datasets. In all three scenarios, the program follows the same steps: storing the data, calculating summations, computing slopes and intercepts, forming the straight line equation, and finally making predictions. This method is widely used in data analysis, machine learning, and system performance estimation. To conclude, the least squares method provides an efficient way to model relationships between variables and make accurate predictions in real world computing applications. Thank you.